Welcome. The purpose of this project is to create a price tracker for any cryptocurrency you choose, just like you're seeing on the screen here, but a little simpler, just a line that represents price and your ability to look for a certain period, interval, and see the trends. I can quickly list you the main features I'll be dealing with throughout. I'll be working with a library called Puppeteer to open a browserless Chromium page in order to retrieve information from a Binance API. I'll also be working with a library called Express in order to set up a request and response route between my Node.js server and the HTML web page. And I'll do it in such a way that you can send data from the server to the page or from the page to the server. I'll be setting up a Node.js server that will be automatically generating that data from the API, that price data that we'll be plotting later. At the same time, he'll be listening to any pings from my web page in order to send the necessary data whenever it's requested. Last detail about the server is going to be a localhost server, not an open port on the web, just local. I will also be using a charts.js library that will be used to chart the data, and you will see it's quite straightforward to use. Lastly, another two libraries that will be coming into use is the course library and the body-parser library. Before we start working on this project from scratch, let me show you what we are going towards. As you can see here on the left, it's a classical Binance trading graph covering the same times range that the graph on the right has, and the graph on the right is my website, which gets that information from my server and plots the same graph. It looks a little different, but it's just the question of scale. Let me just shorten that Y scale and you will see that it is the same data. As you can see, the whole project is built from those two quite small files. One is 130 lines, the other is 120, and one is my web page HTML, and the other one is my server, which is written in Node.js. We can change things on the go on our web page. For example, right now we're looking at the last 1 day of price of Ethereum. Binance USD is just $1, so we're technically just looking at the price of Ethereum. But if we were to change that, we could. Instead of looking at the last day, we can look at 1 hour or 15 minutes or just a minute if you want. And it will display just that time frame. Now that I introduced and demonstrated the functionality of my project and roughly explained how it's going to work and where it sits, I will close this all up and start from scratch and take my time and build this from nothing to what you're seeing now. So if you are looking to make something similar, you can use any part of it. Okay, let me start. I'm going to create a folder and open it with my compiler, Visual Studio Code. I'll also open a web page on the right. We'll use that later. Now, within the folder, we need to create a couple of files. Server.mjs, not just JS, MJS. This is important because this is the way I made it work. It will not work otherwise. Also create a website.html file. And now I'm also creating a text file for notes, but you don't have to do this. I have pasted the 4 required libraries that we're going to be npm installing into our project. Please make sure you go for all 4 of them. I prefer to go for that at the start, so we don't need to do that in between. You can find those npm installs in the video description. After you're done, you should be seeing that node modules folder has appeared and also a couple of package files have appeared. And I will put them in a separate folder just to not look at them every second. First thing we're going to get working is the retrieval of price from the web. We're going to be following the following link that I'm typing. You can also find it in the description as the source of data. It leads us to a Binance API, just one long string of data that gives us information about the current situation of every trade possible on Binance. This whole string is about 900,000 characters long, so there's really a lot of information here, but since it's only text, it's very fast to retrieve it. I will declare this link as a variable so you can use it later to follow it. And before we get into coding, let's import all the required libraries. And instead of using require, I'm using import since we're in an MJS file. It's slightly different, but it still works just the same. Make sure you get that syntax correctly. And as you can see, it compiles. The following lines are the Puppeteer syntax to open a browser, get to a page, follow a particular URL, and within that comment section is what we're going to be doing with that URL, and then we close the browser. Following a particular link does not give us directly access to the information we want. Websites can be extremely complicated and we need an extra path to find the specific part of the website we're looking for. In order to do this, you have to go to our API, right-click anywhere on the screen, choose Inspect, and you will have that window open up. Now, you can see on the top left corner of that window, there is a mouse icon. If you click it, you will be able to look for different elements of our website. Now we can point our mouse at the line with the information we want and click on it. As you can see, that highlights a piece of code in our under elements in this open window. This is actually what we want. Now we can right click that highlighted zone and choose copy and choose full XPath. And that will give us the secondary path to that information. The following lines are going to be using that particular XPath to follow it and extract its content. Let's see what we get if we actually console log that context. We're indeed getting that information from the website. We're getting that huge string. However, it's not in string format yet. I believe it's still a JSON file. So let's add one more line to stringify to make this a string. Okay, now we're getting something we can actually work with. The following lines of code will be dealing with parsing. So we want to eliminate all the unuseful content from this string and get only the useful content out. So we'll be creating step-by-step parsing sequences to get out just the useful parts. The way that the API is holding information is in the following format. You can see on your website to the right that it starts with the word symbol, and then there is the string that represents the trade. For example, the first one is Ethereum versus Bitcoin, and then there is all sorts of information about that particular trade. And at some point, you can expect that it's going to say symbol again, and a new trade will appear. For example, Ethereum versus Binance Coin or something else. So in my mind, the first level of parsing we can do is to eliminate all the unuseful strings before we reach a cryptocurrency we're actually caring about. For example, let's declare a currency we're looking for as a string, and I'm going to looking for Ethereum versus Binance USD. And the first line of parsing will look for that particular substring in the larger string and eliminate everything that came before that. So we established that symbol will come first, and then the name of the trade will come, and then useful information will be there, and then again symbol. So if we eliminated everything before our needed cryptocurrency, then we can say safely that all the useful information will be contained before the next word symbol appears. So what we want to do in the next bit is to delete everything that comes after the next word symbol. We'll use split function for that. Okay, so we managed to reduce 900,000 characters of information to this one paragraph of useful information about one currency we're looking for. And if we're looking for a different cryptocurrency, it would have found that as well. In the next parsing line, I want to get rid of some characters which we will have no use for. So I will replace by nothing characters like tremors, commas, double points, and curly brackets. The only useful information for me is located between the word last price and the word last quantity. So we can use substring again to delete everything that came before last price is encountered, including last price, and then split to remove everything after the word last quantity is encountered. After which we can run it through a parse float, because remember we were still working with a string. And after that we have a number output for the current price of that particular trade. Now we're going to be calling this piece of code quite often, so let's put it in a function, in an asynchronous function. I'll call it scrape price, and I'll add one line of code which will help us handle errors, because sometimes when you call a browser it will fail and not load, and in order for that not to crash our program, I'll add this piece of line. I cannot tell you much more about it, except that it works and that it's not yet working. We're gonna write another piece of line somewhere else to make this error handling work, but we'll come to that later. For now, we're not storing information anymore. We want to create some sort of database, a prices array, where we're going to be storing and pushing into the prices we get from the web. Also, I want to introduce the idea of memory, so that instead of forever accumulating information, at some point it starts rewriting it, and I'll call this variable memory and have a basic if statement to check if the length of our array already reached that maximum memory, and if it did, it will shift it, which means that it will delete the first item in the array and shift the rest in its place. Now I want to create a loop that will call itself when the program starts running, and also that will call itself and keep looping and keep adding information to our array. But I don't want to do it in real time. I don't want it to happen as maximum of time as possible, but instead to have a delay in between. The reason for that is that the API of Binance have limitations on the amount of requests that the API receives. And if I'm not wrong, it takes maximum of 1200 requests per minute, which is about 20 per second. But I don't want to play around with this too much, so I'll set the delay to 1 second, so we're safe. While testing this now, we can see that it works and it calls indeed every second. For you, video is a little bit speeded up, and that the database, instead of always accumulating, at some point stops at a fixed amount and just updates and shifts it in time. Now I'm starting to set up the route between my server and the web page. I know we don't have a web page yet, but we will be making that shortly. I'm introducing port 3000. That's the port on which my server will be listening on. I'm also introducing Express as app. And now I'm starting to create a function which will handle the way responses and requests are handled. So we'll be working with post requests. And for now, we're not doing anything with a request except acknowledging that we received a ping from somewhere. We're ending on that response on that. And the last line is actually the one which will make our server listen. So I'm just clearing the console. You don't have to do that, and logging that we are listening on port 3000. We cannot test the functionality of this as of yet. We need to build the other half on the web page first. Also, we need to define a couple of rules before this request and response route will work properly. We need to work with cores and body-parser libraries to do that. There's not much to implement, but without it, our routing will not work. My knowledge of networking is quite limited, so I cannot explain you why this is what needs to be written, but we need to set up cores and in which we need to define origin, allowed headers, and some credentials. Also, we'll be introducing cores into the Express by using app use, and also the same way we'll be introducing body-parser. I believe this way we'll be able to decode JSON files, but I'm not certain. Last thing before we move on to the HTML, I want to code what kind of information our server should be sending back to all requests. And the syntax of that is to write the identifier, 2 points, and then the data you want to send. Okay, now that we're on our HTML file, I can just type HTML and my VS Code will give me a default template. And now, before we do anything else, I want to import the Charts.js library. In order to do that, you have to go on the website of Charts.js, just type Charts.js, or the link is in the description. Click on the Charts CDN and you will get that coded page. Just copy its link and paste it into the source. We can start our live server now. Perhaps you need to download the extension live server first, but once you have that, you should have your page automatically open. And we're gonna go back to the Charts.js website and get their default template and paste it into our body to test its functionality. As you can see, it is working. We're gonna start changing all those settings immediately now. All I'm doing here is to remove all those unnecessary colors, keeping just one. Changing a little bit the border width, adding some options, for example, removing those ball heads, removing completely the animation, and switching the type of from bar to line. And also I'm putting all of this into an async function charted. Now we can complete the second half of the routing between the server and the web page, and we are going to start by creating a function, async function ping server. So whenever it's called, it's going to send a request to the server, send some data and get some data back. We're going to be sending the buffer time. So I'm creating a variable for that. And the buffer time is the interval of time in which we're interested in having a chart. So we don't want to have all the data all the time. We just want a part of data, last 5 minutes, last 15 minutes, something like that. Inside the function, we're going to be defining that data. We're going to set up options because we need to do that if we want to send a fetch. And it's important that you don't do the same mistake I did here. It's not methods. It's method singular, and post should be in capitals. I will be fixing that later. Headers will define which kind of file we're sending, and we're gonna stringify the data before we're sending it into the body. And the last two lines are our way of fetching and receiving back information and decoding it. As you remember, we're expecting to receive back currency and price array from our server, so we want to create variables for that in our HTMLs. We're going to create a var currency and var prices, just like there. And we're going to be equating those to json.currency and json.price. That's how we're accessing those variables. Finally, we'll put ping server inside charted. So whenever we decide to chart our data, we first ping the server and we receive that information from it. As soon as I fix that error and I switch methods to singular, you can see that we start getting the graph, and whenever we refresh our web page, we got pinged in the terminal. That means our server all the way on the MJS has received that request and told us that it received it. The next thing we're setting up is a loop, just like we did in the server, but now on the HTML page. So we request the information from the server, every now and then given a specific timeout. So I'm just gonna copy it from there and bring it into here and change a couple of things on it. You can see that the only statement we have inside the loop is location equal location. I'm not sure what exactly that does, but I know partially what it does, and it refreshes the page, and that is good enough for me. We keep the charted outside the loop. We actually already have our price array from the server on this HTML page, and we can already go into the settings of charted and change data for datasets to prices, and then it will start plotting it. Even though it is a flat line, it's actually correct. It's just that the price of Ethereum is so high that, and it varies so little, it looks like a straight line right now. So, and this is partially because we are forcing the graph to start from 0. If we comment out that piece of code, it will stop doing that and improvise the axes. I don't really like that, so I'm gonna go ahead and create a function that will make custom maximum y and maximum x for me. Also, you may have noticed I did not change the labels array yet, so we're still going to be looking at red, blue, yellow, and we're going to be limited to 6 data points, but this is okay for now. We will change that later. For those custom scales, we're going to be declaring 2 variables, minimum y and maximum y. We're going to be creating 2 functions, both async, one get access and the other get mean, because I'm going to be using the get mean average of an array, a function inside my get access function. So I'm going to start by this one first. Get mean function expects an array, and then it will cycle through all its values and then yield an average of all those values. I have copied that function from the web, so we'll leave it at that. It works. And then I use that value in my get access to work out some sort of scale which I like. Honestly, this is very subjective, but this is how I did it. You don't have to do it the same way. What I did is that I calculated the distance from the maximum value to the average, and then from the minimum to the average. And then whichever biggest, I took that as scale, multiplied that by 1.5. So in a way, the maximum value will always be 2/3 towards the top of the chart. It's a little bit hard to wrap your head around, but basically what it does is that it takes the biggest difference and then multiplies it a little bit and makes that the default for up and down. Now we can go ahead and to that part of code which we commented out and set min and max to those custom ones, and it will be applied as soon as we refresh. Here I simply replace the label array to prices as well, so you see prices below and above. We'll change that later. And I'm changing the top label by the currency we're currently looking at. We have actually 2 things to fix. First, we're locking the timestamps. We see prices at the bottom of the chart, which is not good. So we need to create a function to create dates and then create a similar array to hold them and similarly pass them onto the HTML web page. That's what we're going to do now. At the same time, I will also introduce a variable called clocks, and that would be also a timestamp, but in the system time. So it's time counted from 1970s, 1st January, in seconds, something like that. And we're going to use that later to implement the interval, implement that we can only look back at a certain amount of time. You can see I added another 3 arrays with the word out in them. It's because we need to differentiate between the arrays that we will send back to the HTML web page and the full array. So there's going to be full, all the data we have, and the out arrays in which we're going to store interval data. Now that we have a way to create a date, we'll go to our scrape price function, and similarly where we push a price into our array, we're gonna push the date into the dates array. And similarly, we'll also be checking if it needs to be shifted or not. Also, we should be going into our post function on the server where we are transferring data back to the web page and add dates similarly how we were transferring prices. Now we can go back to our website HTML and add dates and clocks arrays, which will be holding that information similarly to how prices are. And inside the ping server function, we are gonna implement how we're retrieving the dates from the response. Okay, so now if we go into the charted and change labels to dates instead of prices and restart the server and keep it running for a little bit, we'll be able to see those dates at the bottom of the screen. Now we can do the same thing we just did to dates, but to clocks. You will see me hesitate and take them out and putting them back in. Know that I will actually bring them back, and we're going to be sending clocks across to the website. So similarly, we need to push into the clocks array on the server. We need to shift the array once the memory is reached. We need to pass that information through the post like we did for dates. And when we go to the website, we will collect those clocks over there. Even though I realize we don't have a use for them over there, I'm still gonna do it. Okay, we're creating a function called getData, which will create subarrays of our main arrays with data to send them over to the HTML page, and they will only send within a certain interval. And you will see that's the part where I hesitate with clocks. I will bring them back, I swear. As you can see, I created some copy arrays. The reason I did that is I'm a little bit scared that the main arrays will get modified while this function works to them. So I decided to copy them, which is way quicker, and then work with the copies. Now each price has its own timestamp in form of a clock because we already implemented that. And the last elements in the array will be the latest, and the first will be the first one, the oldest. So what we want to do is start cycling through that array from the top. And once we reach a time which is too far behind, we should stop immediately and not cycle anymore, because that will take a lot of time, especially if the array is very big, that can take a lot of time. So I'm defining the interval time and then using that interval time in the if statements to know when we should stop cycling through the array. Once we set the I to equal to -1, the for loop will collapse. And also you can see we're using unshift instead of push. It's because we're reading the array in the opposite direction. We should be also pushing in the opposite direction. The place we're going to be actually running this preparation data function is in the post that we receive. So in the function where we're handling the requests, we have access to request body and buffer time, which we were actually starting to pass into the server way back. And this is where we're going to be putting that buffer time into the prep data. And now when we switch our response arrays to out prices, out clocks, and out dates, we will be only sending that relevant data. When I come back to HTML and I get those clocks from the response file and I output them, I can see that they're actually not rounded up. So I made a mistake with rounding somewhere in the server MGS, and here I'm showing where I did a mistake and that I'm fixing it. Here I actually want to demonstrate that this feature is working. So you can see that the number on top here on the right is the interval time. So any number which is lower than that time should not be displayed. And as you can see, the list is growing, and once the top elements become lower than that value, which obviously increases as time goes on, they get removed from charting. The absolute last feature we're implementing for this, because this is almost done, is fixing a little bit the buffer time. Because if I want to see a long amount, for example, a day worth of data, it's really complicated to keep in mind 86,400 seconds. So I'm going to make buffer time a combination of days, hours, minutes, and seconds. And I will also display that in the top label on the chart.js so that we can put hours or minutes or days, whatever you prefer, and get that range instead. Okay, I have left it running for a bit. It accumulated 1,000 records, so you can see it works. And if I switch the intervals, it will also follow that correctly. A good step to do here is to, instead of keeping information on the server, is to create a separate database, an SQL database, and keep information about multiple, maybe all currency exchanges in there. So we can, by one click, switch from Ethereum to Binance or to Bitcoin or something else. There's definitely ways to improve here. This project is limited in its usefulness, but I initially put the bar too high, and I am already happy that I could complete a part of it. All right, that's it from me. Thank you.